I love inequalities, Mr. Chase.
You work with Sissy Chase?
Yes.
All right, let's start with a question that isn't an inequality yet, but I'd like to ask just this very innocent question. Here's a function. You're welcome. It's already factored for you. You're welcome. And the question is, what values make this function f of x 0? Or also positive, also negative, and also the question undefined. Julie did this like really tight angle. I'm serious. That's how you It's not too bad, alright. Alright, you done yet? No. So tell me when. I want to know precisely what x values make f of x 0. I want to know exactly what x values make f of x greater than 0, less than 0, and undefined. All right, let's answer the first question. Go ahead, Catherine. What are the Catherine is I've rearranged you guys. I've got to refine you. Where is it 0? Go ahead. Sorry, say it again. What'd you say? Yeah, -3 and 4, and that's it, I guess, huh? Okay. So x equals -3 and x equals 4 are the only places that this crosses the x-axis. And then, what about when is this above the x-axis? That is, when does this function output positive values? And how do you know, too, Shashir?
Well, the second and the third one, these things, they'll always come out positive because the x is getting squared. But the first one, you have to make sure it's positive, so this has to be greater than 3.
Okay, so he's already starting to think about the sign that these things generate. One way you can think this through systematically is to actually start by thinking about how you might graph it, right? Here's the x-axis, here's the y-axis. Actually, I'm not going to draw it because I don't actually care to graph the whole thing. I just want to know when does it go above and below the x-axis, right? So maybe there would be the y-axis if you wanted to put it in there, you could, but so -3 here and 4 over here or whatever. And what he's saying is, if you're to the left of -3, you're below the x-axis, is that what you said? Like if you were to graph this, if you plug in values like -4 or -400 or something bigger, something more negative, or something past on the left, -3, then you get something, well, I don't know. He's saying you get something negative here, times something positive, times something positive. You with him on that? Yeah. So you do get something negative, aka below, if you're graphing it below the x-axis, right? And then what about in between -3? And actually 0 is not of interest to me. I just had it on there, so I'll just get rid of that. I mean, 0 is interesting because that's where the y-axis is, but I don't really care. If we're in between -3 and 4, that's kind of the next place where it touches the x-axis and has a chance to cross the x-axis. I don't know, let's say you're at x equals 0 or x equals 2 or something. In there, what do you get? You get something positive in the first set of parentheses. And then positive still. And this is what Shashir is saying. In fact, it looks like the second 2 sets of parentheses are always going to be positive. Like, it's not even worth discussing, perhaps, for this particular problem. So in the end, you get something positive. It's going to go above the x-axis there. And then last, if you're a number greater than 4, it's still going to be a positive times a positive times a positive. And all right, which makes sense because again, if I asked you to graph this, you would be like 50-degree polynomial, has n behavior like this. It's going to cross And then it's going to come down here and touch and then go, right? Anyway, so that's reflected in what we're saying. I just want to make sure you're clear on this. And in fact, in the end, we don't have to graph it. We just need to kind of have this like sign chart analysis. That's all we need. When I'm plugging in values in each interval, notice I don't even care what I get. I just care, is the result going to be positive or is it going to be negative? And we don't have to check multiple values in an interval. As soon as we know that one value in this interval is positive, we know that they all will be in between, right? Because if they switch signs, what would have happened? Another x-intercept, and we didn't get any more, right? The only chance a polynomial has to cross the x-axis is at a 0. Right, so we know we're good if you just test even 1 point. All right, so it's greater than 0 for values negative 3 to 4 and 4 to infinity. It's negative from negative infinity to negative 3, and it's undefined nowhere. You try. Here's another one. Very similar problem. I just thought I'd give you a chance to take a crack at it. Maybe you need to make it a little curl at the end.
Yeah, but that's like part of it.
It's hard now.
Tell him, Mr. Chase. Tell him he's wrong.
Practice. All right, so we're looking for, again, and I'll call on some people in a minute here. Again, where is g of t 0? Where is it? Greater than 0? Less than 0? And we'll maybe already get our number line set up here. Juliet, help me out here. What are our zeros for this guy? Aren't you done? Oh no, I'll give you another second. All right, we'll Juliet and I will pause. Let's catch up. Sorry if I gave it a word for it. Everything's fine. Nothing to see here.
Greater than. Less than. You're empty. Okay. Put that in your Yeah, you know. T is also the opposite of root 2, right? Root 2 of T. Oh, no, it's not, because you have to divide this.
All right. Let me ask some people here. Could you fill out the sign chart for us? How about a mean? Go. All right, so what do you get here? In this interval, you pick a number like, I don't know, whatever, negative 50 or something. You plug in, what do you get, positive or negative in the first interval? Negative. All right, so what's here? Positive times a negative times a negative? All right. And then what about if a number between negative 4 and 3, pick 0 or something, what happens when you plug 0 and you get a positive number or a negative number? Are you agreeing with, on these guys?
Yeah.
Wait. the negative, wait, positive times a positive times a, plugging in 0 or something, huh? Yeah, so what do you get in the middle? Negative. All right, and then when you're past 3 at like 4 or 400 or something, what do you get there? Yeah, still a negative here. Good. Do you agree with Amin on his analysis? Okay, we just need to write it up. So greater than 0, we said just over here, negative infinity to negative 4, and negative 4 to 3, and 3 to infinity are when we're negative, and undefined nowhere. Okay. All right, now I want you to understand this is not too bad, right? Here's the follow-up question. Here's a follow-up question, which I'd like you to solve, which I think is more in line with the kind of homework problems and the kinds of problems we're desiring you to solve today, actually, than the problem you just did. And it might be a little bit intimidating because there's like no function, and you've never solved like higher order polynomial inequalities before, right? It's a little intimidating until you realize that what? That we can just write down the answer. What's the answer? What's the answer? Negative infinity to negative 4. How'd the people who recognize that so quickly recognize it so quickly? Definitely. Yeah. What'd you say, me?
So, since we plugged in values less than -4, and at the end we got a positive value, and since the greater equal sign is greater than 0 at the end, so all our values have to be positive.
Yeah, this is the same problem as up above, right? I hope you see that, right? This is the same problem as up above. So when you're asked this problem, I want to make sure you harken back to this experience, and you think, oh, this is just this experience, except easier. It's actually only asking me one question, not like a whole bunch of questions. So even though there isn't a function, I still want you to think about this as a function on the left side, which suggests a strategy for approaching one like this, say, right? What's our strategy going to be? Don't actually solve it, but just, I mean, we will solve it. But just tell me what the outline is going to be here. What's your line of attack? You're going to do what, and then what, and then what? I don't know. And then what?
First,
Yeah,
add
exactly.
8x on the other
Yeah,
side.
maybe move it all over to one side so you have a 0 on one side. What's the next thing you're gonna do? Maybe factor it, right? That seems like a good idea. Yeah.
If you solve the other one, you would get exactly the same, right?
The same problem.
Okay, now what we're going to do is that x minus 4, x minus 2, plus better equal to 0.
Like actually solve it.
Always remember, guys, when multiplying or dividing by a negative, flip to the side.
Like if you use the number like
This is how
Aiden, I'm giving people tips.
This is algebra. This is the way to solve these. Yeah, there's not like another strategy. Yeah. Yeah. I'll do that first step for you. There you go.
Yes.
There you go. You're welcome. Where's the pass? Is it my right there?
All of us.
All right. All right. Let's come together. Can you can keep working here, but Vicky, do you have the factorization back there for me? Go ahead. Hey, wait, you stop, you and you. Vicky's talking. Go. X times x minus 2. Superb. Good. Good. Now, do know that in other circumstances, one could make the factoring harder, given the universe, right? But that was nice. All right. You're welcome. You're welcome. Okay. And then Jasmine, take us home on this problem. What are we going to do next? That's right. We're going to draw a number line.
And I just plotted 4 to 0.
0, 2, 4. Keep going.
And then I didn't really get like the plus. I know like that there it would start since it's like it's like the positive. There's no like.
Yeah, it's a cubic looking like this. Okay.
So we have like from negative to 0 to negative, and then from very positive go up and then go down. Between 2 and 4 will go down again. And go back up.
That's true. Absolutely. I mean, the other way to do it is what we were just saying, and just to make sure you understand the signs too. If you plug in like negative 100, here you'll get something negative. Here you'll get something negative, and here you'll get something negative. So that's why, right? I don't even care what we get for y when we plug x equals negative 100 in. I just know that it will be some negative y value, right? And then same thing in here. If you plug in something between 0 and 2, like say x equals 1, if you plug 1 in, you'll get something positive, something negative, something negative. That gives you something positive. In here, if you plug in like 3, you get something positive, positive, and then something negative, which does give you a negative. And if you plug in a number bigger than 4, like a million, you'll get a y value that's positive times a positive times a positive, which is a positive. All right? Anyway, so the point is, I think we're ready to go. Give us our actual final answer. Jaewoo, go ahead. Jaewoo. What's our final answer then? We actually have to answer the question as asked. So x can be in the interval 0 to 2.
Yes, x is positive and 0 to 2. And then, oh, sorry, I thought you were like one of these things.
Yeah.
Like from the x thing. So from negative to 0, x is like negative.
I want to know the answer to this. I want to know what x values make this statement true. I want to know. Yeah, we're looking for the x values that satisfy the statement. Yeah. So, yeah, notice that we're not asking for a list of properties now. We're asking actually for the x values, if you were to pick them from this set of values, would go back and make a true statement at the beginning, right? Okay. All right. Now, the other thing I should say is, what if it wasn't even factorable? Even like after rational root theorem and all that, are we done? Like, is it just we throw our hands up? Well, one way could you use your calculator? So how? If you had like a really terrible polynomial, what would you do? Yeah. Now in this particular example, the roots are 0, 2, and 4, so there's no need to do that. It would take longer to graph it than to do what we just did. But remember you know how to find your zeros on the calculator and all that. So you could, even if it was messy, you could see then from the picture when do the y coordinates go above and below the x-axis. Yeah. Yeah. Do you see why I use closed brackets? Yeah, because this time I'm interested in knowing when also x values that make this equal, and that's those values. All right, listen up. We've been dealing with polynomials, and I'm going to make sure you're clear on this. A polynomial can go from having positive outputs to having negative outputs, only by doing what? By crossing the x-axis. What about with one like this? I mean, it's certainly clear. It's already kind of in factored form. We can start drawing our number line right away. So certainly what needs to be on our number line? Well, I'm thinking the zeros, the only x-intercepts, there's only one, it's negative a half, right? But actually, I think the people who called out some other numbers, they might be onto something, and if so, why? Why would they be onto something about the other places of interest? Like, what's going on there? Reggie, you want to start? Yeah, and they might both go up, but they could. He's saying they could go opposite directions. Think of 1 over x. That changes from having negative y values to having positive y values, and yet it doesn't cross the x-axis. Whoa, what magic. Yes, Juliet. Say it again. If you have a what?
If you have like an interval where it's like positive, you can't include the value, that's not considered.
Yeah, that's true. If it's like a greater than or equal to or something. And this we won't be doing that anyway because it's right. But she's right. We have to be careful about that. Endpoints on intervals. Yeah. Good. So I think now, as we go to rational functions, we also want to include places where the function is undefined. Notice that that just wasn't an issue when we were doing polynomials in the last couple slides. Okay, so, all right, well, now we just go do the same thing. Plug in some values on the left and right of each of these intervals. Keep in mind, by the way, that this is in fact a good way to think about graphing these in homework 5. If you're trying to graph this function, it might be helpful to know when it's above and below the x-axis. So just test the point and see, are you getting positive or negative y values? You know? Go back and use this technology on that homework too. If you plug in negative 50, let's say, something over here, what do you get? Negative over negative times a negative. What will that be? So over here, it's negative. In between negative 3 and negative 1/2, like say we're at a equals negative 2. What are we getting? Negative over positive times a negative, if we're in here. So that's positive. And then in between here, say we're at 0. If a is 0, what do we get? Positive on top. Positive, negative, so that comes out to be a negative. And then over here, if we're at like x equals 1,000,000, or a equals 1,000,000, positive, 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 so we get positive. All right, so now we're prepared to answer the question. Who will do that for us? Remember, actually, we gotta answer the actual question now. Go ahead for now.
So it would be negative infinity to negative 3 not included.
Yeah, we're looking for the places where this is negative, right?
Yeah.
Negative infinity to negative 3, not included, yeah?
Yeah, and then negative 1/2.
Comments there? Yeah.
If we're doing it for the positives, would we? Oh wait, never mind.
Any other thoughts there? Does that make sense? Remember what this tells you about the graph too, right? That already this tells me that the graph has this kind of shape, right? It's like this. And then in here, it's like this. And then here, it's like this. And here, it's like that, right? What's that? Yeah, so that's a great way to analyze this if you were to go graph this next. That's not what we're doing here, but so use this kind of analysis even on the tasks like you were presented with in homework 5. Can we do this one before we leave? Yeah, we can. This will be our last one. Okay, so no big deal. Here we go. So we got to have 0 on there for sure, and 4 looks like. What else we need? Negative 1 looks like a point of interest for sure. What happens to the left of negative 1? Yeah, it's undefined. Right? In between negative 1 and 0, what do we get? Plug in negative 1/2, say. You get something positive times something. What will this be if you plug in negative 1/2 for y? Yeah, that'll be negative over something positive. How about this guy here? Plug in 1 or 2 or something. Yeah, as we cross 0, we get something positive times something still negative over something positive. So this is still negative. And then 4. Looks like finally we're going to get positive, positive over a positive, which is positive. All right, so what's the actual answer to the question? Careful. Someone wanna take this? We're looking for when it's greater than or equal to 0. Yeah. So 4 to infinity for sure. Including 4. Including 4. What else? Also 0, right? What about negative 1? No, not negative 1. All right. Have a great day, guys. Perfect. Again, homework, it's called homework number 8 on your sheet. And the capture sheet. See you on Monday. Have a great weekend. I've been waiting for this day like my whole entire life.
But no, but this time, that missing is for SCR.
You got half to go and go past when you take like you need to figure out how you do that inequality. In fact, we did 200 like x squared. It's not then the next step is not equal, then therefore x squared plus the right? Yeah, that's what I'm saying. So it's still like a little problematic. So some kind of
Yeah, because it's stuff you already know.
You too. Bye, guys.